In this video, we'll learn how to make interpretations from contingency tables. In a previous video, we looked at the results from surveying a group of people who were either male or female and who were Democrat, Republican, or Independent. The contingency table shows or counts. Now, we will be looking at how to interpret information from our table. One way to do this is to draw a side-by-side graph and examine what we see. By looking at the graph, it is easier to make comparisons. We see, for example, that there are more male Republicans than female Republicans in our study, and that the female independents far outnumber the male independents. Another set of interpretations can be made through calculations. Calculating various percentages help us to better understand our data. Before we can start calculating percentages, we need the sums for each row and column, along with the total number of people surveyed. Let's start by looking at what we can interpret from marginal distribution. Marginal distribution are percentages calculated from the margins or the total row and column of our table. Looking at the margin on the right, we see that 42 people out of 130 people overall were Democrat. We multiply that by 100 to see that 32.3% of those surveyed were Democrat. 37 out of 130 people were Republican. 28.5% of those surveyed were Republican. 51 out of 130 people were Independent. 39.2% of those surveyed were Independent. We can take this a step further and start to look at conditional distributions. Conditional distribution focuses on a specific category or categories rather than focusing on the whole sample. Let's look at an example to see what I mean. How do the conditional distributions of independent voters differ for men and women? Since we are interested in the distribution of independent voters, our total is now 51, the total count of independent voters. We see that 19 of these voters are male, 19 out of 51 independent voters. We multiply this by 100 to convert to a percent and get 37.3%. We do the same for females by dividing 32 by 51 and multiplying by 100 to get 62.7%. Being able to calculate conditional distributions give us more insight into our data, showing us exactly how categories are broken up. Let's see another example. Does there appear to be an association between political party and gender? We can take a look at the conditional distribution for each gender. Since there are 60 males, we put each value in the first column over 60 and multiply by 100 to convert to a percent. We get the conditional distributions 33.3%, 35%, and 31.7%. Since there are 70 females, we put each value in the second column over 70 and multiply by 100 to convert to a percent. We get the conditional distributions 31.4%, 22.9%, and 45.7%. Notice that 35% of males are Republican, while 22.9% of females are Republican. The percentages are very different. 31.7% of males are independent, while 45.7% of females are independent. These percentages are even more different. If the percents were the same, there would be no association. But since the percentages are different, we see that there is an association between political party and gender within this group. Here's a summary of what we've learned. Side-by-side bar graphs can be used to draw conclusions from contingency tables. Marginal distribution is calculated from the margins of a contingency table. Conditional distribution focuses on a category or categories instead of the whole sample.